In the last video, we set up the idea of how I'm gonna do these motion problems with speed, distance, and time. But again, the Orca ebook and WebWork will have examples done in a different way. So whichever way works best for you, but I wanna show you a couple examples with my way. So let's do the first example. It says, on her camping trip, Lee spent as much time hiking as she did rafting. So that's the key phrase, as much time. And then we have hiking and rafting. So right away, that sets up an equation that time h for time hiking equals time r for time rafting. And we need to convert times into distances and rates. So what we saw up here and over here is that time is distance over rate. So let's do that. We need to make it distance over rate. Distance over rate. But we need to make sure we're keeping track of which one's hiking and which one's rafting. So I'm gonna just label them H and R. All right, so time is distance over rate, but I have hiking and rafting. And this from just the first sentence. I haven't even read the rest of the problem, right? By knowing the times are the same, we can really set up what the fractions are going to look like. So now let's read the rest of the problem. She traveled 2.5 miles per hour when she was rafting. That's a rate, right? This per hour makes it the rate rafting. So I'm going to put it in the bottom of the fraction. 2.5 miles per hour is the rate rafting. Okay, let's keep reading. 3 miles per hour when she was hiking. So rate hiking is 3 miles per hour. All right, so I set up my fraction. Now I'm just filling in as they tell me the information. If she went 3 miles more hiking than she did rafting, how far did she hike? All right, so we have the rafting and the hiking, and we got to decide which ones are variable, and you can do it multiple ways. Since they're asking how far did she hike, I'm going to let that be x. So I'm going to say let x equal the distance height. So that would make distance height x. But then it says she went 3 miles more hiking than she did rafting. So rafting, in other words, would be 3 miles less, x minus 3. So for example, if she went 10 miles hiking, then that would be 7 miles rafting because she went more hiking than rafting. Now, the other way to do this is to let x be the rafting and then to subtract 3 this way. It's up to you, doesn't really matter. I'm sort of regretting in doing it this way now that if you let x be rafting, then x plus 3 would be hiking. But it's also good to talk about how you can set it up either way. And that's why it's important for us to define our variable, right? That is x the hiking or the rafting, we got to decide, and then the other one is sort of according. All right, so here we have an equation with fractions, a rational equation. But this one is actually easier to solve because it's just fraction equals fraction. We can cross multiply. If there were anything like plus something else, then you can't use cross multiplication. But if it's fraction equals fraction, we totally can. So that gives us 2.5x equals 3 times x minus 3. And we definitely need parentheses around the x minus 3. The x you could put in parentheses, but it's the minus 3 that makes it so that we're going to need to distribute in the next step. So 2.5x is 3x minus 9. I'm going to subtract 3x from both sides. So negative 0.5x is negative 9. Divide by negative 0.5 on both sides. Once we get rid of the fractions, hopefully it's something that is pretty easy to do. X, I think, is 18, but you know, double check on a calculator. The negatives cancel, so it's just 9 divided by 0.5 is 18. Hooray. But then we gotta decide, well, what's 18? So we have to go back to, good thing we defined our variable. Let x be the distance height. So this would be miles height. And then if they wanted to know, they just asked how far did she hike, so that's the answer to that. But if they wanted to know how far she rafted, that'd be x minus 3, which would be 15 miles rafted. I don't know. Rafting, I'll say. All right. A little awkward on that one. Let's try another one, make sure it goes a little smoother this time. So on the next page, we have another example. Eileen and Ben are in their paddle boat, which can travel 8 miles per hour in still water. Okay, so we definitely have some kind of rate. So we have still water is 8 miles per hour. And you can even add, write rate if that helps you. Just remember that's our rate. If the boat takes the same amount of time, there's our key word. Remember that we're going to have a same amount of something, right? Either same amount of time, same amount of distance, or same speed. This one, it's time upstream and time downstream. So time U equals time D, upstream and downstream. And we can even label those better too. Maybe I should. Upstream is on the left side. Downstream is on the right side. Okay, time equals time. So what we need to do then, remember that any speed or rate is always distance over time, like miles per hour. If I rearrange this so that I want to find what time equals, well, I would multiply by time, divide by r, so it'd be d over r. So we need to change this time into distance over rate equals distance over rate. All right, but again, we need to make sure we're keeping track of when is it upstream and when is it downstream. So distance upstream over rate upstream equals distance downstream over rate downstream. And now we're ready to read the rest of the problem, right? I really was just focused on that same amount of time part. So then it tells us we travel 3 miles upstream. That sounds like a distance. 3. And that's against the current. That's interesting. That'll have to do with the speed, which we'll worry about after reading the rest. As it does to travel 5 miles downstream. So the distance downstream is 5. And that's with the current. Then it says find the speed of the current. So what we're trying to find, that's our x. So x is the speed of the current. So we're going to need some x's in here. And we know, I don't even know if we need that. 8 miles per hour in still water, huh? Oh yeah, I think we do. So this boat travels 8 miles per hour in still water. All right, so we have to think about what's going on upstream and what's going on when we go downstream. And it says upstream, we're going against the current. And that's gonna slow us down. That's what against the current means, is that, it's gonna slow us down instead of speed us up. So it's gonna take the rate of 8 and subtract whatever the current is. All right, so if the speed of the current is x, it's gonna take our 8 miles per hour and decrease that. But when we go downstream, we're with the current, and that's gonna speed us up. So it'll take our 8 and add a miles per hour, whatever the current is. Hopefully that makes sense. It's a little different, especially, you know, if we're not boaters, which I'm not. I don't know about you all, but I'm sure some of us are. But let's put, now that we sort of hopefully get this of like what against versus with the current means, we need to put in here. So upstream against the current, the speed is going to be 8 minus x. Downstream with the current, we're going to take our 8 miles per hour and add some speed to it from the current. Well, the nice thing is that we have fraction equals fraction, so it's another one where we can cross multiply. But we'll need to distribute in both cases. So it'll be 3 times 8 plus x equals 5 times 8 minus x. Now that there's no more fractions, it shouldn't be too bad. We just need to do some distribution. So 24 plus 3x is 40 minus 5x. I definitely want to start by adding 5x to both sides, not 50. So add 5x, 24 plus 8x is 40, subtract 24. So what I'm getting is 8x equals, that looks like 16 when I subtract that. So that would be dividing by 8, you get x equals 2. Which makes sense because the boats should be faster than the current. All right, and that's a good reminder. X, make sure you write down what your variable is. X is the speed of the current. So in this case, our current is 2 miles per hour. Is the speed of the current.